Well, good morning, Chem 1. I've been wanting to do a lab with you guys this whole time. I mean, this is the time of year, in all honesty, we do a lot of labs. I know by doing this lab, it's going to put me a little bit behind where the other Chem 1 teachers are, but hey, I'm okay with that. I know we kind of had a little pseudo lab here a couple weeks ago, and that was okay, but I really want to do a lab. This lab I was going to have you do. And essentially what we're going to do is use a lighter, and we're going to look at the butane that comes out of this. I've already measured the mass of it, and I'm going to give you a data table which have all these numbers in it, and your job is simply going to be to calculate. But here's what you would have done in the lab. Now, the first thing that I have set up is a tube with 50 milliliters of water in it. And what I'm going to do is place my lighter in the water and allow the gas to displace the water from the tube. And so let me go ahead and get started with that, and I'll explain a few things this is going on, because this will take a minute or two to do that. And I don't know if you can see very well from the video, because I can't see the video myself. Right now you can see the gas going up into the tube. And if I get my hand out of the way, it's displacing the water. And I have the lighter right in the mouth of the tube. These are burettes. I would have used a udiometer tube at school, or perhaps even just a graduated cylinder to make it a little easier for you to do. Because obviously I had to rig something. Now you may be saying, why do I have these things at home? Well, I just do. Years ago, I worked at a lab that was finishing up, and I asked what were they going to do with all the stuff. They were going out of business, and they said they were going to throw it away. So I said, can I have it? And they said, sure. And I actually took a whole van load of stuff with me, and I ended up donating that to a school in Goshen, and kept just a few things to myself, just more or less to have a little bit of a collection. And I took some to Warsaw, and the rest I just have here. So yes, you've always thought me as being a little bit weird and geeky, and that is very true. I am weird and geeky. Alright, so you can see at this point we have about, I can't read the numbers where I'm at, looks like about 30 milliliters. I'm going to take it down a little bit further. Now the trick to this, and why it would probably be a next day lab, is you've got to get the lighter dry. Because any water in the lighter is obviously going to throw our mass off. And no problems for you guys, because by the time I give you the numbers, the lighter will be dry. You have all the data there, and I hope I've explained it well enough that you can get your calculations finished. And what we're going to do is look at the mass change of the lighter, and then you're going to calculate how much mass of gas is in this tube using your gas laws. And then once you've done that, you're going to compare the two masses. Are they indeed the same? And what I found last year, last year the first year I did this lab, I think it was last year, anyhow, the numbers were very, very close. I was very, very pleased with this lab. And so that's why I decided to go ahead and do that one more time here. I wouldn't mind having just a little, my finger slipped off. Wouldn't mind having just a little bit more gas in here. Because there's a step I got to do here in just a minute that will not make a whole lot of sense to you, because we haven't been in school for me to teach you this stuff. And down at the bottom is where I want to get close to 50. And exactly what I get is insignificant as long as I know exactly what I get. Let me just go a couple more milliliters here. Now, one thing that I didn't teach you this year, and I'm going to stop now, is called Dalton's Law of Partial Pressures. And essentially what that law states is that the law of pressures, the total pressure is equal to the individual components of pressure. What does that mean? It means inside this tube right now we have the butane from the lighter, but we also have some water vapor. I can't help it. Collecting over water, I'm going to have water vapor. So what I want to do then is make sure the pressure inside that is a known. Well, how do I know what that is? If I hold the tube and I move it up and down, so that the water level in the tube is the same as the water level out of the tube. See how that, I don't know if you can see it from there, but the water level is higher now. If you look down below, it's below. And so I want to get it right where it's even. And it's really hard to do because I've got so much diffraction going on. And each of those is in milliliters, so I'm sitting at 2.2 milliliters. So that means I collected 47.8 milliliters of butane. So, right, 47.8 milliliters of butane. And what I'm going to do with that number then is measure. Now, all the thing left for me to do is clean up. You obviously don't need to see me do that. So I'm going to post this video as well as a data sheet. And your job is going to be to finish calculating and finding out how good was I in the lab. What is my percent error? So I'll have these things posted for you tomorrow. Today's Tuesday. I have them posted for you tomorrow. And we'll take a little bit of a break from our other learning. And then we're going to have this lab. So hope this is enjoyable for you. I need to do a lab and trying to think of a lab. You've been around me enough to know I crave doing lab experiments. So I hope that you have fun with this. That's what it's intended to do. Again, I hope all of you are well. I know this is just a crazy situation, and I'm hoping it ends soon. I'm ready to get out and about and do life as well as I'm sure you are. All right, take care, be safe, and I do miss you guys an awful lot. Bye for now.